This video starts our discussion on solving quadratics, so getting the value of x that works in a quadratic equation, just like we were doing with linear equations and absolute values and all this other stuff. And to start things out, I want to call your attention back to a skill that you learned in geometry. I want to solve for x in each of these right triangles here. Now, as you hopefully remember, probably the most important thing you did in all of geometry, most famous theorem, maybe of all time, Pythagorean theorem says if you have a right triangle, a squared plus b squared equals c squared. A and b are the legs of your triangle. Doesn't matter which is which, but c has to be your hypotenuse. Hypotenuse is the side opposite the right angle. So in this problem, I would have 12 squared plus x squared equals 13 squared, and I would solve that equation. So 12 squared is 144 plus x squared equals 169. I subtract 144 from both sides, and I get x squared equals 25. So all of that should look pretty familiar. That's something you practiced in great detail in geometry. Now, if you look at what that is, this is a quadratic equation. We're trying to solve something that has an x squared in it. And if you think back to geometry, how you did that, the way that you solve something with an x squared is by canceling out the squared. You want to get x by itself, which means getting rid of this. And the way that you get rid of the squared is by taking a square root on both sides. Just like adding and subtracting cancel out, multiplying and dividing cancel out, squaring something and a square root cancel out. They're inverses of each other. So when I do that, I get x, and we would put equals 5, and we're done with the problem. Now, on this problem here, I had x squared equals 25. I got the answer x equals 5, and that makes sense because 5 squared does equal 25. Let's take a step back from this problem for a second. I'll write that down again. X squared equals 25. We said the answer was 5 because 5 squared equals 25. It turns out, though, there's a second answer to this problem. There's another number out there that when you square it, you get a positive 25. And the answer to that is x equals negative 5 as well. If we had a negative 5 and we squared it, negative 5 times negative 5 is still a positive 25. So there are actually two answers to this problem, 5 and negative 5. Now you might be wondering why you didn't bother, how is there all of a sudden another answer there? Why don't we just deal with 5 and be done? In this problem, we're talking about a triangle, and it doesn't really make sense for the side of a triangle to be negative 5. So in geometry, we're just kind of like, whatever, and we didn't even bother really talking about it. But if you're just solving an equation, forget about this. If that was just a problem right there, x squared equals 25, you need to put that extra answer in there. And the way you do that is by putting a plus or a minus in front of it. This symbol right here is pronounced plus or minus, and what it means is that positive 5 and negative 5 are both solutions. So you will see that symbol quite a bit in this chapter. This shows there are two answers to the problem. Same sort of deal on this one. If you were doing the Pythagorean theorem, you would set it up. You'd have 4 squared plus x squared equals 10 squared, and you'd solve it. You'll get x squared equals 84 when you do the math. And when we take the square to both sides, this one is not a whole number. So what we're going to do is do our little factor tree on our 84. And I'm kind of going a little quicker through this now because you guys are starting to get used to making those factor trees. Turns out this is equal to 2 root 21. So x is going to be 2 root 21. In geometry class, you may have written your answer as a decimal, which isn't wrong, but in Algebra 2, we like to typically leave it with radicals in them. So you want to simplify your square root when you see this instead of just popping it in your calculator and getting a decimal. So that's why we went over that process in the last video. Now, if you want to be super official, in the equation, this is the only answer, but negative square root of 84, or negative 2 root 21 works as well. So what I'm going to do is put that little plus or minus sign on my problem again. So the square root method has 3 real steps to it. It's probably my favorite way to solve a quadratic because it is fairly fast. Oops. You're going to get the x squared guy by itself. You're going to take the square to both sides. And do not forget to put that plus or minus on your answer. That is a step that I guarantee kids will forget. It always happens. You got to remember to put that plus or minus sign on your answer when you take the square to both sides. So when you do this, step 2, you have to remember to do this right here. So let's go ahead and solve 2 examples of this using the square root method. Both of these problems look like, they kind of like the Pythagorean theorem problems we did in the last slide, except now there's no triangle. So while in the last problems, you could have gotten away with just saying the positive answer, the answer is only 5. Here, negative answers are totally fine. You have to give all the answers. So when you say solve, you want all answers. Positive, negative, doesn't matter. You want all that are possible. So our job is to get the x squared by itself in this problem. And that's going to play out just like it normally did. Like if this was just a plain old x right here, you'd add 9 to both sides. And when you do that, you get 5x squared equals 100. This next step is something that I've never, I see it happen a lot as a mistake, and I'm not sure why, but a lot of kids will just take the square root right now. They'll try doing it right now, and they'll just cancel out the x squared. They know to get rid of the number, but then they mess up on that. You can't do the square root yet, because there's still this 5 right here. If you take a square root, the 5 is going to get caught in there, and it's not going to go away. Well, just like if this was a 5x here, the way you get rid of this 5 is by dividing by 5. So we divide both sides by 5, we get x squared equals 20, and only when you have the x squared by itself can you do the square root on both sides. So we take the square root on both sides to kill off the x squared. We get x equals plus or minus, don't forget that sign, and if you do a little factor tree on 20, it's going to end up being 2 root 5. So positive 2 root 5 and negative 2 root 5 are our solutions. Final problem of the video. Again, I want to get x squared by itself, and in this problem I have multiple x squareds. I got to combine them. So let's say I put my x squareds over here, try to keep the variable positive. And when I move stuff around, I get 162 equals 6x squared. Remember, you want to kill off that squared and get just x by itself, but you got to get rid of the 6 first. We do that by dividing both sides by 6. And when we do that, we're going to get a 27. So we get 27 equals x squared. Now that x squared is by itself, I'm going to take the square root of both sides to cancel it out. If you do a factor tree on 27, it's going to be 3 root 3. So my answer is plus or minus 3 root 3. Again, the biggest thing in this video that you will probably make mistakes on if you're not careful. If you take the square root of both sides like we've been doing in these problems, that's when you put that plus or minus in front of your answer.